Hi, everybody. Welcome back to our return to the linear equation, where we're continuing to review what we learned previously in the hopes that we can learn some new stuff moving forward. Quick little review. What is the difference between a direct variation and a partial variation? Direct means it starts at 0, 0. Now, whether this is in the table, whether this is in the on the graph, there's no starting value. So, for example, so our equation in general is going to look like mx, right? Because b is 0. So, for example, I don't know. I know how you guys like negative numbers, so let's give you negative 3x, just so you can start crying. On a table of values, it'll look something like this. Woo! X's and Y's. Negative 2, 0, 2, 4, and these are just numbers. There's no equation that I'm actually basing these off of. But what I want you to notice is that it's 0, 0 in the table of values. It is 0, 0 on the graph. Now, for partial variation, it means it doesn't start at 0. There is some starting value. And that comes more into play when there's word questions, but it is an important consideration. Now, this is where we get our usual y equals mx plus b. Or, again, just to drive you nuts, here's some lovely fractions, and I can almost hear the eyes rolling from here. It really doesn't matter. Well, the point is that we're adding or subtracting some number at the end. And again, my table of values, negative 3, 7. This is a line. I forget where I got the values from. Might even, oh, you know what? I think it is even based on that equation. Look at me go. 5. Hey, that one is. Should follow my examples more often. But again, it is not through 0, 0. And our graph is not through 0, 0. Just to expand on that a little further, oops, variable. So your b value equals 0. There's only a rate of change. We only have our m. Partial variation, not a variable. Dang it, shouldn't have said that. Variation. B doesn't equal 0, so it's got to be some number. Okay, and again, for those of you who are legitimately in my class, I will rewrite this stuff out so that's a little bit more legible, but we will come back to that later. So yesterday we were looking at graphs, and one of the reminders is that you have to remember to look at the scale. And I was thinking as I did the lesson, like, gee, I really should have included a scale that wasn't 1-to-1. Well, here we have one where each block is worth a different amount. So the block along the, what would that be? Time axis, you'll notice that each block is worth 5. Along the distance axis, each block is worth 20. So now we really do have to read off our scale. Now, I'm not going to mark this up for everything. It's going to get really confusing if I do, but for AB, if we came across and up, m is going to equal, oh, what's my up? 60 over 10, which reduces to 6. Okay. BC, there is no rise. That's over 5 equals 0. Give the last two a try if you haven't paused me already. Remember, down is negative. We're still going to the right. Now this is a fraction, and me being a math teacher and super cool, I want to keep this as lowest terms, because whenever you get into decimals, it just loses something. It loses that je ne sais quoi, and we like having that little extra property in there. Hey, look at that. My example sheet doesn't have the last one there. I guess I actually got to do this. So much easier when I copy. 40, so that's 15. That's 40. So it equals 40 over 15. What's that reduced to? Divide by 5, 8/3. And normally in my classroom, the rule is if you have a fraction, I expect you to put it into mixed terms, so that 8/3 should really be 2 and 2/3. For this, don't do it. Just leave it as a fraction. Leave it as an improper fraction. As we looked at graphing earlier, it actually makes a difference, and when we come back to it later, you're going to see why it makes a difference. All right. So here we have a word question where we're going to tie pretty much everything together. So Semi-Formal is charging $10 per ticket for their dance tonight. Complete the table of values to show their revenue. I don't know why I capitalized that. I guess I was thinking about the revenue service. From ticket sales, graph the data, calculate the rate of change. So in this case, if we sell no tickets, we make no money. If we sell 25 tickets at $10 a ticket, 250. So all we're really doing is we're multiplying by 10. Most of us hopefully can do this in our head. Nick, yes, you are allowed to pull out your calculator if you want to. Of course, here I am saying you can do this in your head, and I've made a mistake. That's okay. Mistakes happen, and we love it. Turn around and graph it. 0, 0 is the nice easy one. What an awkward scale. So I'm going to be lazy and say 100 and 1,000, and connect the dots. Oh, that is a beautiful straight line for freehands. If I do say so myself, you guys had better be applauding at home. All right, so from the table of values, our rate of change. I'm going to give you a bunch of different formulas, and really they mean the same thing, but they're from different sources, so we can't really say it's the rise over run when we're looking at a table. So each of these is 250. And hopefully you remembered to have a look at the n as well. We have assumed that it was just a 1, but we also learned that if it's not, we got to deal with that. So we found delta y there, delta x here. So when we come in and sub in, 250 divided by 25 equals $10 per ticket, which is good because that's what we know, $10 per ticket. Graph m equals rise over run. Now, we could call it delta y over delta x when we're working off our graph. That is possible, because really we're dealing with x's and y's, and that is true. So same thing, 1,000 divided by 100 equals $10 per ticket. I'm going to call out text. And as I said when we were talking about the table of values, what our rate of change is, you can see this underlined portion, $10 per ticket. Well, guess what? That means it's $10 per ticket. Who says math is hard? Spelling is. That's supposed to be a C. And that's it for today. Have a look and see what your homework is. Try to make those connections, but as you can see, whether we're looking at the table, whether we're looking at the graph, whether we're looking at the words, it should give you the same answer one way or the other. So wherever possible, whatever one you're most comfortable with, use that strategy first, but start to look at to see how it's interconnected and all related and really swirly and jurly together, and have fun with it, guys. Good luck.